Hello everyone, in this video you are going to learn more about calculations in series and parallel resistors by Timothy and Joseph. That is my name. So I have done a video lesson about series and parallel resistors. If you have not seen it, find it on my Facebook page. To begin with, for those of you who don't know what series and parallel resistors look like, I'm going to show you. Series and parallel resistors are just the two types of uh, electrical circuits that we have. So let's take a look at what a series resistor looks like. So this is an example of series resistors arrangements in the circuits. So you can see the resistors 1, resistor 2, resistor 3 in series arrangement connected to a certain voltage of battery, and the current is flowing in one path. So a series circuit has only one path in which its current can flow, just like what you are seeing on the screen. The current is flowing clockwise from one resistor to another resistor, and then to another resistor, and then to other components in the electric circuit. So you can see, so a series circuit has only one path in which its currents can flow, and the equation for the combined resistance is just for you to take the sum of the resistors given. That is, you are going to have something like this. That is, the combined resistor is going to be R1 plus R2 then plus R3. And if you have just two resistors, so it's going to be the sum of the two resistors. If you have three, just like what you can see on the screen, if you have four resistors, it's going to be the sum of the four resistors. So that's going to give you the combined resistance. Okay, right. So let's take a look at what a parallel resistor uh, looks like in an electrical circuit. Okay, so this is a parallel resistor arrangement in the circuit. So we have three resistors in this circuit, and you can see that the flow of current is not just in one path, like that of the series resistors arrangement. So the currents are flowing in different parts. So a parallel circuit has two or more paths for currents to flow through all the components in the circuit. So just like what you can see on the screen again. So a parallel circuit has two or more paths for currents to flow through how the components in the circuits. And then the combined resistance can be calculated by using this simple equation. So let me write it on the screen for you to see. So uh, this the combined resistance is given as this 1 over R1 plus 1 over R2 plus 1 over R3. So this will give us the combined resistance. Okay, so let's consider uh, some examples for you to understand this lesson properly. So example 1, you can see it on the screen by yourself. A 3 ohm resistor and 6 ohm resistor are connected in parallel with each other. The parallel is connected in series with 6-volt battery of negligible internal resistance and a 4 ohm resistor as shown below Take a look at the diagram. You can see the information given in the question on the diagram as well. Calculate one, the combined resistance of the 3 ohm resistor and the 6 ohm resistor in parallel. 2, the total resistance of the circuits. And 3, the battery currents. Then the last question, which is 4, the power supplied to the 4 ohm resistor. So let's do this calculation together. So let's do our calculation here. So in our first question, we are going to calculate the combined resistance of the 3 ohm resistor and the 6 ohm resistor in parallel. So the combined resistance. Okay, we know what to calculate, so let's just take away this so that we can save space. All right. So to do this, we are going to apply the uh, formula according to Ohm's law. So we have resistor 1 and resistor 2. So we can name this 1 and 2. So which is going to be 1 over R1 plus 1 over R2. Yes. And then we substitute our value into this. So we have 1 over 3, yes, plus 1 over 6. And then we take the LCM of these two guys. So we take the LCM. So our LCM is going to be 6. Don't forget. So let's not forget this. It's very important to write it. So 6 is going to be the LCM. I don't need to explain this to you. You are a mathematician. 2. So 6 divided by 3, we're going to have 2, and then 2 multiplied by 1, we have 2 here, plus 6 divided by 6, we have 1, 1 times 1, we've got 1, and then we should have 3 over 6, yes, 3 over 6, and this can cancel itself, 1, this cancel this, so we've got 2, so we should have 1 over R equal to 1 over 2, and when you take the inverse or you cross multiply, R times 1 is R, and then 1 times 2 is 2. So this is the combined resistance. So let's put the unit 2 ohms. Very simple to calculate. You can see. Okay, let's do the second one together again. The total resistance of the circuit. The total resistance of the circuit is just the sum of this and this. Okay, so total resistance will be total resistance no, you should be ECE. Okay, total resistance is just going to be 4 ohms plus these 2 ohms. So we have our resistance as giving us this 4 ohms plus 2 ohms, and we have our total resistance as 6 ohms. Excellent. Yeah. Okay. The next question says the battery currents. The battery current, that is the currents that is flowing through these circuits. Okay, so let's calculate that, and that is point C, the battery currents. So to calculate the battery current, so we are going to apply this equation. The battery currents. Write it here. So to calculate the battery current in this circuit, we apply this equation according to Ohm's law. Current is given as voltage divided by the resistance, which is the total resistance, and then we just substitute and then we get our answer. So our total resistance is 6 ohms, and then the voltage in this circuit is 6 volts. So we just do this. So the battery current is going to be just 1.0 ohms. Sorry, amps. Ampere, 1.0 ampere. Okay, yeah, more excited. So let's see. And the last question, the power supplied to the 4 ohm resistor. Mhm. The power supplied to the 4 ohm resistor. So that is the last question that we have. To do this, we are going to apply this equation again according to Ohm's law. Power is going to be I square, which is our current, multiplied by the resistance of resistor. So P, what is the current? Current is 1.0, so we've got this 1 square times the resistor, which is 4 ohms. So we're going to have 4 here. And then the power supplied to this 4 ohm resistor is going to be 4 plus 4, 4.0 watts. So that is units. So very simple. So we're done with this first example. So you can see, once you can remember the formula or the equations, you have no problem. So just apply the equation, substitute, and then straight away you do your calculation and get the answer. Take a look at it again. Very simple to do. Okay, let's move to the next example, which is example 2. Let's clear the screen. Let's clear the screen and then consider another example. Example number 2. A 2 ohm resistor and a 4 ohm resistor are connected in series with each other. The series combination is connected in parallel with a 9 ohm and a 3-volt battery of negligible internal resistance as shown below. Yes, you can see, take a look at the diagram again. We have the 2 ohms, yes, 2 ohms or 2 resistor, 4 resistor, 9 resistors, and then we have 3-volt battery in the circuits. Calculate the total resistance of the circuits, the battery currents, the power supplied by the battery. So let's do this together again. Apply the equation. So we okay. The total resistance of the current. So let's put that here. As the first, the total resistance. So in this case, we are going to this is these two resistors are in series, so we're going to add them together, and then when we add them together, we make them to become parallel to this one, which is going to be six resistors, and then here nine resistors. So we are going to just say 6 ohm. Okay, let me just write it here. Series. So this is series. Oh, I don't like this R, man. I don't like this R. Okay. Okay. So R1 plus R2. So just look at them. This is one, this is two, and this is three. So here we are going to make them to become parallel to this now. So we are going to say 2 plus 4. And then our, how am I writing R like this? So we are going to have 6 ohms, which is parallel to this now. So to calculate the total the resistance of the circuit, so we are going to apply our equation again. So where we have 1 over R equal to equal to 1 over 6 plus 1 over 9. Yes, this one. Then we take the LCM. Yes. So what is going to be the LCM of 6 and 9? Someone say 36. It's big. So let's use the smallest number. So let's take 18. Yes, 18. It's going to be the LCM of 6 and 9. If you use 36 is okay, but yeah, it's big number, but let's just take the smallest LCM. So 18 divided by 6 is 3. 3 times 1 is 3. Yes. Okay. And 18 divided by 9 times 9 divides 18 how many times? 2 times, yes. And then 2 times 1 is what? 2. Yep, yep. 2. So, okay. So 3 plus 2, what do we have? 5, of course. And then divided by 18. Again, let's cross multiply so that we can get the value of R. So R times 5 is R, 5R. Oh, okay. Let's just do it this way. And then 1 times 18 is 18. So here we are dividing both sides by R. Sorry, by 5. So we divide both sides by 5 to get the value of R. So then we have 18 divided by 5. And then what do we have here? Oh my goodness, very long. So 18 over 5 should be 3.6, not just 3.6. Let's put the units 3.6 ohms. So this is the total resistance in this circuit. Okay, let's do the next one, which is the battery currents. The battery currents. The battery currents. The battery currents, for us to calculate the battery currents, so we are going to apply our equation again, that is I equal to V divided by R. So the battery current. Okay, so Let's apply this equation again. I is given as V divided by R according to Ohm's law, and then we'll just substitute the value. So I is equal to, what is our voltage? 3, and then our total resistance has been calculated as 3.6, yes, 3.6, then we divide, when we divide, so we should have, what do we have? 0.83. Yeah, so this is the current flowing in this circuit, and our units amperes. So it is very important, so that units. And then the power supplied by the current, the last question. The power supplied by the current. So for us to do this last question, calculate this last question, is the power supplied by the current. So we apply this equation again, where our power is given as current, square of current multiplied by the resistance. So we have calculated our current as 0.83 amps. So we just substitute. So the power is now 0.83 square times the resistance. What is our total resistance? Total resistance has been calculated as 3.6 ohms. So we multiply. So when we multiply these two together, so we should have, what do we have? Take the square of this and multiply by 3.6. So what do we have? There's a point here. Okay, so we should have approximately 2.5. Yeah, so this is the power supplied by this battery of 3 volts. So 3.5 watts. Let's put the units, quite important. So you can see that it's very simple to calculate series and parallel resistors. So the calculations are straightforward once you can just remember the formula. So this is where we're going to stop in this lesson. Go through it, find more examples or more problems, and try to practice what you have learned. If you have any questions, please just write me in the comments box. I'm going to respond to your questions. Thank you for taking your time to watch this video. Please do like it, share it, so that I can get to many students who need to learn this. Share it, please, and follow my page. Thank you.